Alright, so in today's video we're going to be going over linear equations. This is our first video in terms of linear equations. So we're just going to define what a linear equation is, how we can tell what it looks like mathematically, and then we're going to solve a few basic linear equations. So what is really a linear equation? Well, a linear equation in kind of simple terms we can say is anything that has one variables. Okay, so maybe something like x, y, z, whatever, some sort of variable. Another thing that it has to have is coefficients. Okay, so coefficients, something like the number -2 or 7 or 5/2, for example. These are all coefficients and they can be part of our linear equation. And the last thing that we'll say is that it needs to be of degree 1. So what does this mean? Degree 1 basically just means no exponents, okay? And when I say no exponents, I mean no exponents on our variables. So for example, we cannot have x squared. This would not be a linear equation. We can't have something like the square root of y, because the square root of y can be rewritten as y to the exponent 1/2. So this wouldn't be a linear equation either. Okay, so no exponents. And that's all we need for a linear equation. So some examples of linear equations we can have in very general terms, we can write it as ax plus b equals 0, for example, where we'll say where a and b are both some sort of a number. So in other words, they are coefficients. And in this case, x is our variable. Okay, so again, we don't know how to solve this, and this is not solvable unless we actually have numbers for a and b. But in general, this is what it'll look like. So for example, we could have 3x plus 2 equals 0. In this case, our coefficients of a and b have been changed to +3 and +2, and our variable is x. So this is, in fact, a linear equation. Another example of a linear equation could be something like -5x equals 2. This is another linear equation. Again, we have two coefficients here, -5 and +2. We have a variable of x, and it is of degree 1, so there's no exponents. So this is in fact a linear equation of some sort. And finally, we can have something like x equals 4y. This is also a linear equation because it has coefficients. It has a coefficient of 4. I suppose there's also a coefficient in front of the x. We could say that there is a 1 here if we wanted to. Okay, so we have our coefficients. Our variables, we have two variables in this case, the variable x and the variable y. But it's still a linear equation because it's of degree 1 as well. There's no exponents on our x and there's no exponents on our y. So we can say this is a linear equation. Let's go over quickly some examples of things that are not linear equations. So in general, we can say that ax squared plus b equals 0 is not a linear equation. And the reason that it's not a linear equation is because of this exponent 2. The exponent on the x makes it not a linear equation. Similarly, if we have something like 3 times the square root of x plus 2 equals 0, this also isn't a linear equation because of this square root sign, right? The square root can be rewritten as the power of 1/2. And so this wouldn't be a linear equation either. Likewise, if I have something like -5 times x to the exponent -2/3 equals 2, this also is not a linear equation, again, because of this -2/3 exponent. And finally, if we have something like x equals 4y to the exponent 3, again, not linear because of this exponent of 3. Okay, so that goes over what is and what isn't a linear equation. Now let's get into some examples and solving those. So we're actually going to solve these two examples here. The first one being 3x plus 2 equals 0. So let's say I have 3x plus 2 and that's equal to 0. How am I going to solve this? What does it mean to solve this? Well, what it means is that we need to figure out what number is x in order to make this equation true, in order to make the left side equal the right side. In this case, the right side is equal to 0. So I ask myself, what number can I put in for x to make the left side equal to 0? Now, of course, I could just guess and check. I could say, well, what happens if I put the number 0 in here? Well, if I put 0, 3 times 0 is 0, 0 plus 2 is 2, 2 obviously doesn't equal 0, so 0 doesn't work. Okay, let's try 1. If I put in 1, I get 3 times 1, which is 3, 3 plus 2 is 5, 5 obviously doesn't equal 0, so it's not 1. I can try 2 and 3, and I can try the negative numbers as well, and eventually I would probably get an answer. But in math, we don't want to guess, and we don't want to just be randomly throwing numbers into places. We want a surefire way of solving this, and that surefire way actually isn't that difficult. What I'm going to do is I'm going to isolate this variable x. So the x is going to be left alone on the left-hand side of the equal sign, and whatever is on the right-hand side is what x is equal to, because x will be equal to some sort of number. So how am I going to do that? Well, the first thing that I'm going to do is I'm going to get rid of this plus 2. And the way I'm going to do that is I'm going to take 3x plus 2, and I'm just going to subtract 2 from it. And on the right-hand side, I'm going to take whatever is on the right-hand side, in this case 0, and I'm going to subtract 2 from that as well. And what we're going to notice is that our equation itself won't change, but what will change is where this plus 2, now a minus 2, where it's going to appear. So we can see on the left-hand side of our equal sign, we have a plus 2 and we have a minus 2. So if I have plus 2 and then I take 2 away from it, I have 0. So what I'm really going to have on the left-hand side is just 3x plus 0. And of course, we're not going to write the plus 0. So I'm just going to be left with 3x. So the plus 2 and the minus 2 are going to cancel each other out, and I'll be left with 3x. And that is going to equal 0 minus 2. Well, 0 minus 2 is just negative 2. Pretty simple. And now just like we canceled out this plus 2 on the left-hand side, we need to somehow cancel out this 3 on the left-hand side to get x to be alone. And the way I'm going to do that is I'm actually going to divide by 3. Okay? And again, whatever I do on the left-hand side, I'm doing to the right-hand side too. So in this case, I'm going to have negative 2, and that's just going to be divided by 3. Now on the left-hand side, what I can see here is that I have 3 times some number divided by 3. Well, let's kind of think about that. If I have 3 times 2 and then I divide by 3, what do I get? Well, 3 times 2 is just, let's do 3 times 2 divided by 3. Well, all I'm going to do is 3 times 2. Okay, that's 6, and 6 divided by 3, and 6 divided by 3 is just 2. So what I can see is that I can just cancel out this 3 and this 3 and go straight to my 2. And same thing we can do here. This 3 and the 3 in the denominator are going to cancel each other out, and I'm going to be left with just x. Sorry, just x. And on the right-hand side, well, I'm going to be left with negative 2 over 3. I'm going to leave it as a fraction. I don't want decimals, so I'll leave it as a fraction. But that's my answer. At the end of the day, I get x equals negative 2 over 3. Okay, cool. What exactly does that mean for us? Well, that means if I go all the way to the beginning, where we got our question of 3x plus 2 equals 0, it means that this x is equal to negative 2 over 3. meaning that if I substitute negative 2 over 3 wherever I see an x, I'm going to get whatever is on the right hand side, in this case 0. So if that's the case, let's double check our work. So in order to double check our work, we're literally going to do what I just explained. We're going to substitute negative 2 over 3 wherever we see an x in our original equation. So our original equation is 3x plus 2 equals 0. Now we're going to substitute. So wherever I see an x, I'm going to substitute negative 2 over 3 plus 2 equals 0. And now we're going to solve this equation. And if our left-hand side is equal to our right-hand side, we'll know that we did a good job. So this one is fairly simple. Again, we have a 3 in the denominator and a 3 in the numerator, so they can cancel out. Let's just say that you forget to cancel these out. Maybe for some reason you just forgot. Doesn't matter. Let's solve this. So 3 times negative 2 is negative 6 divided by 3 plus 2, and we're saying that that's equal to 0. Negative 6 divided by 3 is going to be a negative number, and 6 divided by 3 is 2. Plus 2 equals 0. Negative 2 plus 2 is 0, and we have 0 equals 0. Again, you can go straight from this step to basically this step, but again, let's say you forgot, you can always just expand, simplify, and then solve. Okay, so that's our first example solved. Let's go to our second example of negative 5x equals 2. So in this case, negative 5x equals 2. This one is actually even more simple than the previous one. So let's go through it. Again, I want to get this x to be alone. And right now it's being multiplied by the number negative 5. So how am I going to get it to be alone? Well, I'm just going to divide by negative 5. And whatever I do to the left side, I have to do that to the right hand side as well. So I'm going to take 2 and divide it by negative 5. Okay? So again, on the left hand side, the negative 5 and the negative 5 will cancel out. And I'll just be left with x equals negative 2 over 5. Again, I'm going to leave this as a fraction just so that we can be as accurate as possible and so that we can plug it back in and try and solve. So let's do that. Let's double check our work and we'll plug in negative 2 over 5 wherever we see an x. So our original equation is negative 5x equals 2. And again, wherever I see an x, I'm going to substitute it with negative 2 over 5. Okay, and then again, similar to how we had in the previous example, this negative 5 and this 5 and this negative will cancel, and all I'll be left with is 2 equals 2. And I mean, 2 obviously equals 2, so we know we did a good job. Again, if you forgot how to do this, you can do it the long way and do negative 5 times negative 2 over 5. So negative times a negative is a positive. 5 times 2 is 10. Divided by 5 equals 2. 10 divided by 5 is 2. 2 equals 2. Okay? So in both cases, it works. And it works really well. Let's go over our last example now. So our last example was x equals 4y. Now, what you'll notice in this example is that our previous techniques don't really work, right? Because we've already isolated for x, right? X is alone here, and it's equal to 4y. It's not just equal to a number, it's equal to 4 multiplied by some number that can be changing, and we don't know what that number is. And if we try and isolate for y by dividing both sides by 4, all we're going to get is x over 4 equals y. And again, we run into the same problem where y is equal to something unknown, right? And again, there's nothing really further that we can do. So what do we do in this case? Well, in this case, we're not actually just going to get one answer. We're going to get multiple answers, and lots of them actually. So if we look back up here, you'll see that when we solved our problem negative 5x equals 2, we got an exact number for x. We said x is equal to exactly negative 2 over 5. In this situation down here, when we have two variables, x isn't just going to be one number. X is potentially going to be one number, and then it can be another number, and maybe it can even be a third or a fourth or a fifth number. We'll have actually infinitely many numbers that x can be, and infinitely many numbers that y can be. And when that happens, we can actually visualize it, and we can visualize it on a piece of graph paper. And so that's kind of what we're going to be doing in the next video. We're going to be solving x equals 4y, or y equals x over 4, and we're going to be visualizing it on a piece of graph paper to see what it looks like.